So before I start showing you how to balance equations, there are states. These are all at room temperature. So solid is S, liquid is L, gas is G, aqueous solution is AQ, and aqueous solution is something that can be dissolved in water. And I'm not going to be putting these in because it's a bit too much for the eyes and it's just too much to fit into these equations. Okay, so the golden rules. Mr. Holdell taught us a lot about these, so I'm going to go over this. So number one is pretty much just saying that both sides have to be balanced with the same amount of atoms. So if there's hydrogen, there's to be hydrogen 2 on the right side. So create an atom list. I don't like to do that. I like to put the, let's say H is here. I like to put the 2 underneath. I just think it's easier for me, but it might be different for other people. But this is what I like to do. It just takes up less room. So 3 and 4. Well, this should be the high, like the top of the list, because if they're not correct, then why are you doing this? It's not going to make any sense at the end. So this is going to be 1. And this will be 2. And everything else is just shifted down. Alright. So you have coefficients to change the numbers of atoms, never change the subscripts. That's pretty much saying for, see over on this side, they add this 2 to make this balance, and they can't change this 2, because if that changes, then that screws up the whole equation, because if you change this won't be water, it won't be anything. But you can change the amount of this to change the amount of atoms on the right side to equal the left side. So always change the big number instead of the small one. O and H, this is just for an example you use, so I don't know what that is. Polyatomic, so this is what I'll get into. Sometimes you keep them in this group, sometimes you don't, blah 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 blah, no biggie. So yeah, I always want to use the smallest coefficient, so I'll get into something else too, where I have to find what 3 and 2 goes into, and you can do 12, but that's just too high, so go to 6. H2O, I don't get this, this is dumb, I like my way better. And then this just doesn't even work for balancing equations. Trial and error, well yeah, I'll get into that too. You gotta screw up, and it's not like you can always have it perfect the first time, sometimes you might, but sometimes you gotta change it. Double check your work. Who does that? Just get that out of there. Okay, now to balance equations. So this is how I like to do it. I like to put a line under each element so I know the values, and it's just a lot easier for me. So here's 2, here's 2, hydrogen is 2, oxygen is 1. Now balance these. Hydrogen 2, already balanced, so that's fine with us. Now I always like to start from left and go to right. So oxygen 2 and oxygen 1. So that doesn't work. And you can never do a 0.5, always has to be a whole number. So you multiply this guy by 2, cross these 2 out. That'd be a 2, and this would be a 4. So now oxygen are balanced, but hydrogen isn't. This will be 4, and this is 2. So now multiply this by 2, and that becomes 4. Hydrogen 4 and hydrogen 4, oxygen 2 and oxygen 2. Perfect. First one's done. Now we move on to the second. So, same thing as before. 1, 2, 2, and 3. Okay. So now, aluminum and aluminum. 1 here, 2 on this side. So, you multiply this by 2, but I'm not too sure, so I'm going to put a bit higher and a bit smaller. So it'll be 2, oxygen 2, and oxygen 3. So you have to find the lowest common denominator to get it to balance. So 3 and 2 go into 6. So 2 times 3 is 6. 3 here, 6 there. 3 times 2 is 6. Cross it out, cross it out. This will be 6, and this is 4. So now these two aren't aligned. Aluminum, just they're not balanced. So now to cross this guy out, you gotta multiply it by 4. So aluminum 4, oxygen 6, and oxygen 6. Perfect. Now for the third. Now this is what you call a double replacement reaction, because there are 2 compounds on each side. So 1, 2, 1, 2. So first, like before, 1, 2, 1, 1. This is a polyatomic. Sometimes you separate them, but for this example, you don't. Magnesium 1, hydroxide 2, salt 1, 1. Salt for 1 for both. Okay, so now magnesium in here, they're both already perfect. chloride 2 and chloride 1. So you gotta multiply this guy by 2. So 2 here, cross both these out. 2 and 2. Now for sodium, this is 2, this is 1. So multiply this by 2, cross those out. 2 and 2. Now sodium and sodium. Now hydroxide. Hydroxide's 2 on this side and 2 on this side. So it works out perfectly. So there you go with that. Okay, so now we're going to start on polyatomics. It's kind of the same gist, but with more elements put together. So no big difference. So the same as before, values underneath. 1 there, 2, 2, 1, 1, 1, 1, and what do you know? 1. Okay, so calcium and calcium both work perfectly because there's 1 here and 1 here. Now for nitrate, there's 2 of nitrate on this side, and there's only 1 on this side. So we have to multiply this guy by 2. 2 there, cross that out, 2 and 2. So now nitrate is balanced. Now for sodium, sodium 2 on this side, and what do you know? Sodium 2 on this side. So those are balanced. Now we need sulfur. Sulfur 1 on this side, sulfur 1 on this side. Perfect. That was an easy one. Now we just need to move on to the next biggie. Okay. So now, same thing as before. 1, 3, 2, 1, 2, 3, 1, and 1. Okay. So now, iron is 1 on this side, yet iron is 2 on this side. So you multiply this by 2. 2 there, cross it out. 2, this be 6. So now we go on to nitrate. So nitrate is now 6, yet this side is only 3. So we're going to multiply this compound by 6. 6 there, cross those guys out. 6 and 6. Now, ammonium is 2 on this side, yet 6 on this side. So we're going to multiply this guy by 3. There's 6, and this guy will be 3. So now, carbonate is 3 on the left side, and carbonate is 3 on the right side. So there you go. Balanced out. Polyatomics aren't that hard, but you just gotta learn it.